This session is about Kohlrausch's law and its applications. What is Kohlrausch's law? It can be stated as below. At infinite dilution, total molar conductance of an electrolyte is equal to the sum of the molar ionic conductances of individual ions, or molar ionic conductances of cations and anions. This is the statement of Kohlrausch's law. But actually it states that when the solution is reached at infinite dilution, we are taking a solution, and on continuous addition of water, solution finally reaches a situation where dilution is infinity. Under such condition, total conductance of electrolyte is equal to the sum of the molar ionic conductances of individual ions. Example, lambda infinity of AB. What is AB? AB is an example of electrolyte, general example of electrolyte. Lambda infinity of AB equal to lambda A plus, that means conductance of cation, plus lambda infinity of B minus. Lambda M infinity of AXBY, another salt, equal to X into X number of AY plus and Y number of BX minus. Specific examples are lambda M infinity of NaCl equal to lambda M infinity of Na plus plus lambda M infinity of Cl minus, and similarly lambda M infinity of aluminum sulfate equal to 2 into lambda M infinity of Al3 plus plus 3 into lambda M infinity of SO4 2 minus. You never write lambda M infinity of 2 Al3 plus, that is wrong. Instead we have to write number at first, then lambda M infinity of Al3 plus. In that way we have to write. So there is a significant question remains here. Why this relation is valid only at infinite dilution? At infinite dilution, sum of the conductances of ions belongs to the total conductance of electrolyte. At all other conditions of dilution or concentration, such relation is invalid. So definitely we have a question. How to explain it? At infinite dilution, the electrolytes are completely ionized, and due to infinite dilution, interionic attraction vanishes. So the individual ions are free to move through the solution with maximum speed, and they conduct to their maximum. At normal concentration, most of the solutions have conductivity less than the conduction at infinite dilution. It is because of the interionic attraction. Due to their interionic attraction, especially ions with opposite charges, their mobility get reduced. Because of their reduced mobility, conductance also very low. When we are adding water, slowly and gradually, interionic attraction vanishes or decreases and finally vanishes. When there is no attraction between the ions, they can move with their maximum mobility. Then their conductivity is also maximum. Example, for KCl, lambda M infinity is 130. NaCl it is 108.9. Difference is 21.1. Here KnO3 and NaNO3 difference is 21.1. These two examples actually indicate that conductances of K plus and Na plus are always equal irrespective of the anion with which it is binded. Here anion is Cl minus, here anion is NO3 minus. Even if anion is changed or removed, here ion is K plus and Na plus, here ion is K plus and Na plus, the difference is always same. That means under infinite dilution, cations are not under the influence of anions. Cations are not under the influence of anions. This is true in the case of anions also. Under such a condition of infinite dilution, anions are free to move through the solution without any effect of cations. So they can exhibit their maximum value of conductivity irrespective of the counter ion with which it is binded. That is why we are telling that Cold-Roche's law is applicable only at infinite dilution. Now we have to see the applications of Cold-Roche's law. What are the applications of Cold-Roche's law? First one, determination of lambda m infinity of weak electrolyte. Now I have to ask question, how to determine lambda m infinity of strong electrolyte? Have you heard about it? Definitely you have the answer if you have heard the previous video. There we are explaining the graph and told that lambda m infinity of strong electrolyte can be determined graphically by extrapolating that line to the y-axis, but that was impossible in the case of weak electrolyte. So that impossible parameter can be determined here using Cold-Roche's law. Lambda m infinity of weak electrolyte can be determined, but to determine the lambda m infinity of a weak electrolyte, you have to know the values of 3 strong electrolytes. For one weak electrolyte, we need to know the values of 3 strong electrolytes. How to find lambda m infinity of 3 strong electrolytes? That is possible through graphical method. Then we are taking example CH3 COOH is a weak electrolyte. In order to get the lambda m infinity of this acetic acid, we have lambda m infinity of acetate plus lambda m infinity of H plus. These are the two ions produced from acetic acid. At infinite dilution, they are completely ionized also. To determine the value of acetic acid, lambda m infinity of acetic acid, we have to take 3 strong electrolytes CH3COO Na, HCl and NaCl. In first electrolyte we have CH3COO minus. In second electrolyte we have H plus. In first electrolyte we have CH3COO minus and additionally we have Na plus. That is not required to find out the value of acetic acid. In second electrolyte we have an additional Cl minus. We need only acetate and H plus, but in salts we have Na plus and Cl minus additionally. To cancel out the effect of Na plus and Cl minus, we have to subtract NaCl from the sum of these two values. So lambda m infinity of CH3COONA equal to lambda m infinity of CH3COO minus plus lambda m infinity of Na plus. That is first equation. Lambda m infinity of HCl equal to lambda m infinity of H plus plus lambda m infinity of Cl minus, that is 2. Then lambda m infinity of NaCl equal to lambda m infinity of Na plus plus lambda m infinity of Cl minus, that is 3. We have to add 1 plus 3, 1 plus 2, and then subtract 3. So we have lambda m infinity as at 8 plus Na plus H plus Cl minus Na plus minus Cl minus, then plus Na plus minus Na plus cancel, plus Cl minus minus Cl minus cancel. Then we will get lambda m infinity of CH3COO minus plus lambda m infinity of H plus, that is actually the value of lambda m infinity of acetic acid. In order to get this value, we have to add lambda m infinity of CH3COONA plus lambda m infinity of HCl minus lambda m infinity of NaCl equal to, you have to write it. So strong electrolytes 3 in number, then we will get lambda m infinity of a weak electrolyte. Suppose we have to find the lambda m infinity of NH4OH, that is another weak electrolyte. To get the value of this compound, we need to know the values of 3 strong electrolytes, NH4Cl, then NH4 plus is present. For NaOH, for OH minus we have NaOH, so NH4 plus and OH minus, okay, but additionally we have NaCl, so subtract NaCl from these two. This will give the final answer. So it is you to decide, or you to select the proper electrolytes for calculating the lambda m infinity of weak electrolyte. Second application is calculation of degree of dissociation. Calculation of degree of dissociation, that is alpha. Alpha equal to lambda m c by lambda m infinity. What it means? At 1 molar concentration, at 1 molar concentration, lambda m, this is concentration, this is lambda m, lambda m is found to be 200. When solution is diluted to 0.1 by adding 10 times water, then we will get an increased lambda m, that is 250. Again diluted, then we get 320. Again diluted, we get 390. Again diluted, we get 420. And it is continued up to infinite dilution, where the value is 500. So the lambda m is actually dependable on the concentration, which in turn dependable on the degree of dissociation. At 1 molar concentration, small amount of electrolyte is dissociated. when concentration is reduced or dilution is increased, again dissociation increases. Again diluted, again dissociation increases. With dilution, again dissociation increases. So dissociation is connected to concentration or dilution. So degree of dissociation of weak electrolyte can be calculated here. If you have been asked to calculate alpha at 0.1 molar, 0.1 molar, then you have to do 250, that is lambda mc, lambda m at that concentration divided by 500. If you are asked to find the alpha at 0.001 concentration, then you have to do 390 by 500. So lambda mc means molar conductance at that particular concentration, and lambda infinity is the molar conductance at infinite dilution. It actually give you the alpha. Alpha means degree of dissociation or number of molecules dissociated out of the total molecules taken. This is also applicable in the case of weak electrolyte. Then third one is dissociation constant. Dissociation constant K can be calculated. From Ostwald dilution law, you may have studied this relation K equal to C alpha square by 1 minus alpha. For weak electrolyte, alpha is very low. So in denominator, alpha can be neglected and relation becomes K equal to C alpha square. This is the third application. And now we are at fourth application of Kohl-Roche's law, that is the determination of solubility and solubility product. You know the symbol of solubility product, that is Ksp. So we have to determine the solubility and solubility product of sparingly soluble salt. For example, AgCl, barium sulfate, lead sulfate, etc. are sparingly soluble salts. Let us consider AgCl as an example, and we are going to determine the solubility and solubility product of this AgCl. For that, we have to add pure AgCl in a conductivity cell containing conductivity water, and it is heated to ensure the maximum solubility and then cooled to 25 degrees Celsius. Then solution become a saturated solution. Since AgCl is a sparingly soluble salt, very small amount of AgCl is dissolved in that conductivity water. So that solution can be considered as a solution at infinite dilution. Normally soluble salt we are adding to water, then excess of water is added again and again to take it into infinite dilution. But here we are taking definite amount of water and the dissolved salt is very low. So that solution is equivalent to a solution at infinite dilution. Here conductivity water containing AgCl is used for measuring the conductance, and we will get G, measured conductance of that solution. When multiplied with cell constant, we will get conductivity, that means specific conductance of AgCl solution, that is with us. So after measuring the conductance G of the solution using this conductivity cell, we will get K, and this solution is considered to be at infinite dilution because the salt is sparingly soluble. So lambda m of this solution equal to K into 1000 by m. That is the equation, K into 1000 by m. but since this solution is considered to be at infinite dilution, we can write it as lambda m infinity equal to k into 1000 by, instead of molarity we can write it as solubility. Since it is a sparingly soluble salt and it is a saturated solution and it is at infinite dilution, due to these three reasons we can equate solubility with molarity, or we can write solubility instead of molarity. So solubility is obtained, S equal to K into 1000 by lambda m infinity. How to get K? That is already been calculated using conductivity. We have an equation 1. How to get lambda m infinity? It is the lambda m infinity of AgCl. So lambda m infinity of AgCl can be determined from the value of lambda m infinity of Ag plus and lambda m infinity of Cl minus. From these two values, in problem you may be given with these values, then you will get lambda m infinity of AgCl. Then S is obtained. What is S? Solubility is obtained. For AgCl ionizes as Ag plus plus Cl minus. If AgCl has a solubility S, then concentration of Ag plus is also S, Cl minus is also S. Then Ksp equation is concentration of Ag plus into concentration of Cl minus, then S into S. So Ksp equal to S square. S square. So we have calculated S as well as Ksp. This is the fourth application. Now we have to see fifth application, that is the determination of ionic product of water. What is ionic product of water? What is ionic product of a solution? It is the product of molar concentration of ions in that solution. Here we have water with us and we have been asked to calculate the ionic product of water. Ionic product of water is nothing but the product of the molar concentration of the ions in water. What are the ions in water? H plus and OH minus. So Kw, the ionic product of water, is concentration of H plus into concentration of OH minus. By applying Kohlrausch's law, we can write lambda m 0 of H2O, lambda m infinity or lambda m 0, both are same. Lambda m 0 of H plus plus lambda m 0 of OH minus. The value of H plus lambda m 0 and OH minus lambda m 0 are given, 349.8 and 198.5. Then adding these two we will get 548.3 ohm inverse centimeter square mole inverse. That is the molar conductance at infinite dilution of water. And at room temperature, the conductivity of water is measured to be very low. That is 5.54 10 raised to minus 8, by very low. At normal condition of temperature and pressure, water is a very weak electrolyte. It is feebly dissociated and the ions produced by water is negligible. Since water contains very less number of ions, conductivity is very low. So conductivity is practically calculated to be 5.54 into 10 raised to minus 8 ohm inverse centimeter inverse. Since water is dissociated feebly because of its weak electrolytic character, it may be considered as a very dilute solution of H plus and OH minus ions. So again, we are considering this water as a solution at infinite dilution. So lambda m infinity of water or lambda m 0 of water equal to K into V. Then we will get V. What is V? V is the volume of electrolyte containing 1 mole of the water. Then only it become molar conductance. 1 mole of electrolyte should be there. then only this equation become lambda m, or this term become lambda m. So V is the volume of solution containing 1 mole H plus and OH minus in centimeter cube. So V equal to lambda m0 divided by K. This is the equation. Lambda m0 is here and K is also we have, where is K? This is K. Then 548.3 by 5.54 10 raised to minus 8 centimeter cube. So what is V? V is the volume of water containing 1 mole of H plus and 1 mole of OH minus. From where we have got 1 mole? By definition, if there is 1 mole of water, then only we can write it as lambda m. So here 548.3 divided by 5.54 into 10 raised to minus 8 centimeter cube of water contain 1 mole H plus and 1 mole OH minus. Then 1 centimeter cube of water contain, then it will be go to the right side. It become 5.54 10 raised to minus 8 by 558.3 mole H plus plus this mole of OH minus. 5.54 10 raised to minus 8 by 548.3 moles of OH minus also. This term is to be right here also. This is in 1 centimeter cube. So in 1 liter means 1000 centimeter cube. This parameter is to be multiplied with 1000 because it is for 1 centimeter cube. We have to get the value of 1000 centimeter cube or 1000 ml, then multiply with 1000. Then we will get 1.01 into 10 raised to minus 7 H plus 1.01 into 10 raised to minus 7 OH minus. This is the number of H plus ions and OH minus ions in 1 liter of water. What is ionic product? It is the product of molar concentration of ions in 1 mole of that solution or 1 mole of that electrolyte. 1 liter of that electrolyte. It is the molar concentration, product of the molar concentration of ions in 1 liter of the solution. Then in 1 liter we have this much of H plus and this much of H plus OH minus. So Kw equal to 1.01 into 10 raised to minus 7. This is for H plus into 1.01 into 10 raised to minus 7 for OH minus. Then we will get 1.02 into 10 raised to minus 14 mole square per liter square. This is Kw. This is already you have studied in ionic equilibrium, but in electrochemistry through conductivity measurement and by applying Cold-Roche's law, this relation can be reached. That is proved here. So in fourth and fifth application, you have to consider the solution of sparingly soluble salt as a solution at infinite dilution, and here water is a weak electrolyte, so water can be treated as an electrolyte at infinite dilution since it contains only limited number of ions. From that consideration only we can apply Cold-Roche's law. So while discussing these applications, you never forget to write that statement. This solution can be treated as solution at infinite dilution. That is must to explain the things and to reach the final answer.